Hi, my name is Paula, and I'm talking to Michael Stephen, a main board director of the Symphony Environmental Technologies Group. Michael, before you joined the board at Symphony, you were a practicing barrister for 20 years, and then a member of Parliament. While you were an MP, I think you were a member of the Select Committee on the Environment. Did this have anything to do with your joining Symphony?
Yes, it did in a way. When I was on the Environment Committee, I became aware of the dreadful problems caused by plastic waste, which did not get collected for proper disposal and escaped into the open environment all over the world. And we've all seen the television programs showing the plastic accumulating in the oceans. I became aware that Symphony had found a way to deal with this problem. So I was pleased when they invited me to join them after I came out of Parliament.
Plastic has got a really bad name these days. Is this justified?
Well, yes and no. Like many scientists, many non-scientists, I had not been aware that plastic is really a miracle of chemical engineering, which was invented by some very clever people. Just think, a plastic film only a few microns thick is immensely strong and durable, and it's not expensive to produce. I think it's the best material by far for protecting food and many other goods from damage and contamination, and for reducing food waste. It's much better than paper, especially if it gets wet, and its global warming potential is lower. In addition, and particularly important during this pandemic, plastic can be made so that it protects us against bacteria and viruses. Perhaps we can talk about that later. But I think it's really unfortunate that plastic has been demonized in the last few years. We're witnessing an almost hysterical plastophobia, which is not good for human health or the environment. We all want to make waste management better, but what do we do about the failure of waste management? The only problem with plastic is that if it gets into the open environment at the end of its useful life, it can lie or float around for many decades, some people say for hundreds of years, before it becomes biodegradable. Now, as we all know, governments and NGOs, including Britain's Department of the Environment, have paid a lot of attention to this, and we know about their proposals for reducing, reusing, and recycling. But there's a gaping hole in their policies, isn't there? It must be obvious that you can't use or recycle a product or take it to a composting facility if it's escaped into the open environment from which it cannot realistically be collected. And we all know that a significant amount will escape for the foreseeable future. It seems to me that governments and NGOs are behaving as though this part of the problem did not exist. They're simply ignoring it. But fortunately for us today, some of the scientists who were working with plastics in the early days were aware of this problem, and they found a way to make the plastic convert automatically into a biodegradable material at the end of its useful life. One of these scientists was Professor Gerald Scott, who patented the technology, and he later became a chief scientific advisor to Symphony. I had the privilege of knowing him at that time. Unfortunately, the plastics industry did not adopt this amazing invention, and they continued to make ordinary plastic, which started to accumulate in the oceans and has now become a serious problem. About 20 years ago, both the problem and the solution were identified by Symphony's founder, Michael Laurier, and the company has developed Professor Scott's invention into one of its main technologies. It's now marketed in 96 countries around the world, and it's even been made compulsory in the Middle East. But still, not everybody understands it, even in the UK.
So how does D2W technology work?
Well, the reason why ordinary plastic can last for decades in the open environment is because although it will fragment into microplastics, its molecular weight is too high for the microbes to access it and cause biodegradation. So our scientists have put together a very sophisticated package of chemical ingredients, which they call a master batch. And this is put into the plastic products while they're being made in the factory. The master batch contains pro-degradant catalysts and stabilizers in exactly the right balance, so that during its useful life, the plastic product performs in the same way as an ordinary plastic product and should be disposed of in the same way. And this upgraded type of plastic costs little or no more than ordinary plastic. But the crucial difference is that if the plastic does not get collected and is left in the open environment, the catalyst will cause it to oxidize and reduce its molecular weight so that it becomes a waxy substance which is no longer a plastic and can be consumed by the microorganisms. This is why it's called oxo-biodegradable. And it will convert into biodegradable materials much more quickly than ordinary plastic would. And it will then be recycled back into nature by the bacteria and the fungi, leaving no toxic residues. And this has recently been confirmed beyond doubt by a 5-year study called the Oxymar project, sponsored by the French government at their marine laboratory in the south of France. And their report was published in March of this year.
But some people are saying that you are creating microplastics.
Yes, I've heard that too. In fact, it's well known that almost all the microplastics found in the environment today are caused by the fragmentation of ordinary plastic after it has been exposed to weathering. And that is why it should all be upgraded with oxo-biodegradable technology at the point of manufacture. Now, ordinary plastic is oxo-degradable because it degrades in the presence of oxygen, but it does not become biodegradable except over a very long time. By contrast, our D2W plastic is oxo-biodegradable. The European Commission asked their scientific experts, the European Chemicals Agency, to study oxo-biodegradable plastic in 2018 because the Commission thought that it created microplastics. We submitted a substantial dossier of technical evidence to the agency, and so did many other people. And 10 months into the study, the agency announced that it was not convinced that microplastics were formed. So we were astonished when the European Parliament ignored the European Union's own technical experts and decided to ban what they called oxo-degradable plastics. This ban is actually the subject of a legal challenge brought by Symphony against the European Union in its own courts. And perhaps we can talk a little about that later.
You have said that plastic is very useful and that Symphony has found a way to prevent it accumulating in the open environment. But doesn't it require a lot of fossil resources to make plastic?
Not really, because oil is extracted from the ground to make fuel for engines. And plastic is made from a byproduct of refining the oil called ethylene. It's also made from natural gas. Maybe there'll come a time when fossil fuels are no longer needed as a fuel for anything. But that is quite some time in the future, even in the Western world. Until then, it seems to me to make sense to use the byproduct to make plastic rather than using scarce land and water resources and fossil fuels to grow crops to turn into plastics. Some energy is, of course, required to convert the ethylene into plastic, but this is much less than the energy required to make paper, glass, steel, or aluminium, or to make plastics from crops.
A few minutes ago, you mentioned recycling. Doesn't biodegradable plastic play havoc with recycling if it gets into the plastic feedstock?
Well, if it's bio-based plastic of the type marketed as compostable, it will certainly contaminate the recyclate and cause problems because it's a completely different material and contains a much higher water content. And I can understand why recyclers would be worried about it. But by contrast, oxo-biodegradable plastic is almost exactly the same material as ordinary plastic and can be recycled in the same way if it gets collected. And many thousands of tons have in fact already been recycled all over the world without any problems. The only difference is that biodegradable plastic contains a very small amount of the pro-degradant catalyst, usually less than 0.5% of the plastic. And if this gets diluted by being mixed with ordinary plastic, it will no longer be effective. But in order to be sure about this, we arranged for tests to be done by expert laboratories in Austria and in South Africa. And they both concluded that oxo-biodegradable plastic can be safely recycled with ordinary plastic. And these reports are on our website. But actually, recycling is a bit of an irrelevance when we're talking about oxo-biodegradable plastic, because it's typically used for low-value polyethylene and polypropylene film, which is often contaminated. Usually, it does not make economic or environmental sense to recycle it anyway. Recycling is a good idea, but it's not suitable for everything. Recyclers are, of course, primarily focused on their own industry, but they're concerned, I hope, like all of us, with the long-term pollution of the open environment caused by plastic, which does not get collected for recycling. Unfortunately, negative comments in the past by some recyclers, who perhaps are not aware of the points I've just made, are delaying the acceptance of oxo-biodegradable plastic by some people. So it would be very helpful if they would make it clear that they're not actually opposed to it.
You also mentioned that Symphony has brought a legal action against the European Union in connection with the Single-Use Plastics Directive. Why was Symphony advised to do that?
Yes, as I said, the European Parliament ignored the European Union's own technical experts, the European Chemicals Agency, who considered many hundreds of pages of scientific evidence and were not convinced that microplastics are formed by oxo-biodegradable plastic. Indeed, the European Parliament bypassed all the rules and safeguards laid down in the REACH regulation and simply decided to ban what they called oxo-degradable plastics. These rules and safeguards were carefully worked out in cooperation with a wide range of stakeholders when the REACH regulation was being developed, and they were intended to prevent the kind of arbitrary and commercially motivated legislation which has happened here. We've been advised by a very distinguished team of experts in European law that the European courts are not likely to find this behavior acceptable, and we're claiming a very large sum of money as compensation for the confusion which has been caused and the consequent damage which has been done. And the reason why I say that confusion has been caused is that the European Parliament and the Commission have failed to distinguish between oxo-degradable plastic, which does create microplastics, and oxo-biodegradable plastic, which does not. They think they are the same, when they're obviously not.
Thanks for that explanation, Michael. You mentioned earlier a type of plastic marketed as compostable. Is it really compostable?
Well, no, it isn't. It does not convert into compost because the very standards it has to comply with require it to convert into CO2 gas within 180 days, not into compost. These standards are European Standard 13432, American Standard D6400, and similar standards in Australia and elsewhere. And for that reason and other reasons, many industrial composters and local authorities, from Oregon in the United States to Epsom in the United Kingdom, are saying that they do not want it in their composting process. And worse still, to my mind, lobbying for this type of plastic is a distraction to governments trying to deal with the main plastic problem facing them today, which is the pollution caused by plastic waste, which does not get collected and ends up in the open environment, and especially in the oceans. It seems to me that if you can collect a piece of plastic, there are better things to do with it than turn it into CO2 gas in a composting facility. which contributes to climate change and provides no benefit to agriculture. Not only should this type of plastic not be marketed as compostable, it should not be marketed as biodegradable either. And the Danish courts have considered this and decided that it's a deceptive description because consumers would think that it would biodegrade in the open environment. But in fact, it is tested according to the international standards I've just mentioned to biodegrade in the special conditions found in an industrial composting unit.
So far, we have talked about biodegradable plastic, but you mentioned earlier that Symphony has found a way to upgrade plastic so that it protects us against bacteria and viruses. Can you tell us about that?
Yes, our scientists have created a formulation which is put into a wide range of plastic and rubber products, and we have received test results from an independent laboratory showing that bacteria and viruses will be inactivated within 1 hour of coming into contact with it. This is much better than spraying or wiping because it's embedded in the product itself and it will not wear off. It can be used in personal protective equipment and on tabletops, door handles, and every other type of plastic or rubber that people touch. And I hear that one of the cities in Brazil has just decided to use it on its bus network. Now, our scientists have also made plastic lethal to insects, such as flies and mosquitoes. And they've also made the plastic sheathing of electric cables so that it no longer gets eaten by rats and mice. And they've made irrigation pipes which no longer get punctured by insects. They've also made water pipes and tanks which no longer suffer from the buildup of slime on the inside. And they've also made plastic packaging which extends the life of food, and plastic packaging which prevents corrosion of metal items. Recently, Symphony's bread packaging has been approved by the Food and Drugs Administration in the United States. And you can see a short description of all these technologies at www.d2p.net.
Michael, you are the chairman of the Oxo Biodegradable Plastics Association, as well as the director of Symphony, and you write a weekly column in Bioplastics News. Can you tell us about that?
Yes, I used to write critical comments about articles in Bioplastic News, which I thought were mistaken. And one day I was surprised when the editor invited me to write a weekly column. I make it quite a controversial column, and the editor tells me that it's widely read by senior people in governments and companies all around the world. And I'm happy to write this column because I think it's really important for the future of the environment that as many people as possible understand the issues that we've been talking about in this interview.
Thank you, Michael Stephen, for discussing these important subjects with us today. People who are interested can find out more information on Symphony's website and on the website of the Oxo Biodegradable Plastics Association.